Stan Jabalisco here from the Black Hills of Dakota Territory, United States of America, with a little tip for you for drawing schematic diagrams, also block diagrams, and in general any kind of electrical or electronic circuit diagrams. This video is especially relevant to my book, which recently came out, or I should say it came out in October of 2013. Whether or not that's recent, I guess depends on when you're watching this video. I plan to leave it up indefinitely. This is the third edition, Beginner's Guide to Reading Schematics. The previous two authors should get some credit for having provided the foundation for this book, Traister and Lisk. But McGraw-Hill wanted me to rewrite it, so I did. Actually, redrawing most of the art was the primary project goal here, in addition to providing some additional explanations of how circuits work over and above the second edition. The book starts out simple enough. Block diagrams is where it really begins. Block diagrams look like that, or if you prefer to use the spiral paper-bound book here to its best advantage and fold it back like that, it'll lay flat on your workbench and you can build a circuit that'll provide power to a strobe light. You can build an AM radio transmitter, as long as you have each individual stage all pre-assembled. Shows you how to hook them together. That's the kind of thing that a block diagram does. Flow charts, computer programs. Book gets into components, symbols, simple diagrams, schematics, progressively more and more complicated ones, split up among pages, etc., etc. 170 odd pages. Paper-bound spiral edition needs no battery, needs no boot up, does not acquire any bugs or viruses, and will only get wet if you spill your Diet Mountain Dew on it. But the little tutorial here, the purpose of this little tutorial, is to show you how quadrille paper can be used to advantage in drawing block and schematic diagrams. Notice there's a 9 by 12 inch sheet of paper in a notebook with a whole bunch of them, spiral bound, divided up into 1/4 by 1/4 or 1/4 by 1/4 inch squares. So I guess I'm not sure why they call it quadrille, but in any case, they also call it graph paper. Notice that these quadrille lines are not particularly prominent. You don't really want them to be. All you want them to be there for in these applications is to make sure that you get your lines straight, like this. Here's a block diagram. Let's see. Let's suppose we have an antenna. We have a preamplifier, followed by an RF amplifier, weak signal RF amplifier, followed by a detector, followed by an audio amplifier, an AF amplifier, followed by an audio or AF filter, and finally going to a headset. You might want to add arrows to show the sense of the signal as it flows, because it doesn't always go from left to right here. It sometimes goes from top to bottom, sometimes goes from right to left. You can recognize this, can't you? You can probably recognize it as an AM or amplitude modulation receiver. And the filter helps to get rid of the high-pitched buzz and static that would otherwise be so annoying in your headset. There's your antenna. Notice how this is, even though it's rather rough, of course, because it's hand-drawn, notice how the lines go essentially horizontally and vertically. They don't get all skewed all over the page. That's why quadrille paper is so handy for drawing diagrams like this. Now, in the video just prior to this one, I showed you some basic schematic symbols, including, for example, an incandescent light bulb, a resistor, and a solar battery. And here's a little circuit. Let's call the resistor R1. Guess we can call the bulb B1. I'm not sure what they abbreviate bulbs as. I believe, though, that this book has a table in it that gives you some of the standard abbreviations for symbols, letter designations for components. Incandescent lamp is I. I sub 1. Incandescent lamp sub 1. Now, you might look at this circuit and think, first of all, why would you want to put a resistor in there? Just make the bulb the right size to work with the battery. Well, let's suppose you had a 48 volt, huge 48 volt solar battery, but your bulb was only intended for 12 volts. You'd want a resistor there. But here's another thing, and I'll bet you're wondering this already if you're astute, aren't you? Why on earth would we want to power up a light bulb with a solar battery? Okay, the sun is out, and you're going to use solar power to power an incandescent light bulb? I mean, won't the sun itself provide enough daylight to do whatever you need to do? Well, first of all, I'm just weird, and I wanted to see whether or not you'd catch this before I showed you how silly it is, except, of course, if that incandescent light bulb happens to be inside of an otherwise dark enclosure, such as, for example, a recreational vehicle or the basement of your home. But then the question becomes, why would you use an incandescent light bulb, which is so inefficient, and not an LED light bulb? And the answer is, you would use an LED these days. An LED light bulb. I've recently replaced all of the bulbs in my house with LED lamps, light-emitting diode lamps. They're really cool. Let me show you one. Yank a few of them out of my, they happen to be in my kitchen drawer. Isn't that the logical place to keep light bulbs? In your kitchen drawers? There's an LED light bulb. It's the little LED thing is in that little nubby in there, and it provides the equivalent of about 25 watts of light, 25 watt incandescent light bulb equivalent, but it only takes, let me see how many watts. Does it tell me on here? 2.3 watts to get, it's more than a 10 to 1 advantage. Here's another example of an LED light bulb whose outer plastic covering broke off. It's also 25 watt equivalent. Sort of a different configuration. Still works even though that thing broke off of there. You know, another neat thing about these bulbs over compact fluorescents is you can break these and it won't give you a health hazard, you know, where you have to wear a hazmat suit to clean it up and all that stuff. But I'm diversing, but that's my right, I guess. That's my habit. Stan Jubalisco from the Black Hills of Dakota Territory, United States of America. Hope you get something out of this little tip for using quadrille paper to help you scrawl your schematics by hand, which I'm sure all of you are just eager to do. Beginner's Guide to Reading Schematics. Beginner's Guide to Reading and Drawing Schematics. Until the next video, have a good one. So long.